use often. One is time. The unit is second. Symbol is yes. The second one is electric current. The unit is ampere. The symbol is A. The next one is electric charge. The unit is coulomb. The symbol is C. Of course, we use the unit of length is meter. Symbol is M. Next, let's review the prefix. One of the typical one is gig. We know that the gigabytes hard drive, that's 10 to the power of 9. And megabits, megabytes, symbol is big M. Kilo, we know kilometers, kilograms, symbol is K. Next typical one, we use milli, so millimeters, milligrams, symbol is M. And then micro, 10 to the power minus 6. And the symbol is mu. Nano, 10 to the power minus 9. The symbol is N. And pico, 10 to the power minus 12. The symbol is P. The unit of nano and pico are often used in the capacitor values. Current measures the movement of charge in a conductor. Historically, people thought that current is caused by the movement of positive charge, which is actually not the case. Actually, the movement of electrons causes the current. So, when we talk about current, we talk about the directions, in which direction the current will flow, and also quantity of the current, how big the current or how small the current is. The direction of the current here, in this case, is marked by the opposite movement of the negative charge. The negative charge moves in this direction to the left, and then the current, the direction of the current is actually to the right. So the definition of the current is defined as the opposite flow rate of negative charge. This is an illustration. Here we have a segment here. So the current is the number of negative charges passing through the segment in a unit of time. Current is measured by 1 coulomb over 1 second. This is measured in the unit of amp called 1A. As we see that the current measures the change of the charge. So mathematically, we take the derivative of the charge with time. So dqt dt. The current is function of time, so we use small I of t. Using this relationship, what is the total charge transferred from time t1 to t2? So we simply do definite integral from t1 to t2. The integrand will be the current IT. Please note that big Q here is a value. Here it's just a value, not function of time, because T1 and T2 are given. Okay. This relationship here, thinking of the water flow, there's a pipe here, water coming out here, and then there's a big container here. And how much water, 1 o'clock to 3 o'clock. So the water in the container equals water flow rate multiplied by the time duration. If the water flow is constant, is uniform. But sometimes if the water flow rate is not uniform, we need to do integral, like here. So you need to do integral from T1 to T2. So here, I use this water tank, use this example to explain this mathematical relationship.